Hello, my name is Ethan Page, and today we'll be having a look at the linked list data structure that I programmed for my CSC 382 class. As you can see here, there is a menu that I've set up, just a basic thing. We'll be going through most of these options, and then I'll have a look at the code. Start with inserting elements. Option 1, I'll insert 6 elements, 1 through 5, with an extra number thrown in, because I'll then delete it later. Now if I print the list, option 4, you can see 1, 2, 3, 4, 456, and 5, and backwards, again, show that this is a doubly linked list as opposed to singly linked. Now if I want to find an element, I can look for 456, and it will return the value and the pointer location. This is more just of a test, a use case sort of thing, as in order to delete 456, I need to find the location of this data so that it can be deleted and everything can be reassigned. Now we only have 1 through 5 in the list. If I look for the maximum, it will return 5. If I look for the minimum, it will return 1. Now if we have a look at the code, this is a menu. The more important things here are input protection. I ask for an integer, so I'm making sure that it is in fact an integer. Outside of the menu, however, the more important code is up above. Let's start from the top. I have a templated node with room for a data and a head and a tail, a before and after pointers to the previous and next nodes respectively. The add node takes in a pointer to a pointer to the head node, the initial one, so as a value, and then uses that data to create a node, insert values based off of what's entered, and thus create a new node, especially if it's the first one. Makes it the start of a new list. Delete node takes in the same reference, a pointer to a pointer reference, as well as another pointer, the node to delete. That's where the find data comes in handy in a moment. It then cycles through looking for the node to delete based off of the pointer passed in, and cycles through until it's found, and then sets the pointers of the previous and next nodes to reference each other, thus removing it from the system, as it were. Now the find data is important here because you can pass in a value as well as a reference to the pointer of the head node, and it will then go through and try and find that node. It will then return a pointer to it, which is why these two work so well together in my code, is because in order for this to even take effect, well, people are going to remember the value of it more easily than they're going to know where the data point is located. Finally, the print list here goes through and will iterate through the entirety of the list and print all of it, both forwards, which also has a little bit of setup here for backwards, to then print it backwards. Just again, the sake of it's a doubly linked list, not singly. Max value then takes again the same reference, pointer to a pointer, and then starts iterating through the list and measuring against each data point, and it will replace a temporary value with whichever value is larger than it, and then display the max once it's gone through the entire list. Minimum does the same thing, but with small values instead. All in all, a fairly simple data structure. Easier to code than I thought it would be, but hey, that's why it's a simple one. Thank you very much, Ethan Page.